Hey there, Mr. Sutton here with the IM3 Honors 5-3 Extra Practice Number 5 solutions on Rational Roots Theorem. There's a puzzle that goes with this one. Let's go check that out. So here's the puzzle we're trying to solve. If figs come from a fig tree, where do chickens come from? A chick tree? Probably not the answer, but that's my best guess. But to actually get the answer, on all these problems we're given one of the roots, and these are kind of some weird roots. These are like imaginary numbers. We have to use something, probably synthetic division, to break these down and find the remaining roots. Once you've got a root, or the remaining roots anyway, check it out over on the column of answers on the right here, and whatever letter's next to that, we're just going to put that above the problem number on the slots down below here. So let's see what the answer to this riddle is. For our opening problem, we have this polynomial, and we're given the root 3i. Now I'm about to do it using synthetic division, but if you wanted to, this one you have a 1 to -2 ratio for the first two terms and also the last two terms, so you actually could have used grouping on this one, but let's do it the synthetic division way. So let me set up my coefficients. We've got 1, -2, 9, and -18, and then a box number of 3i, which is kind of strange, but we're going to roll with it. So we bring down our 1, times 3i gives us 3i. And now i's in real numbers are not like terms, so I can't actually combine these. I have to write the sum of these two as -2 plus 3i. Next, I've got 3i times this. That's going to be -6i plus 9i squared. 9i squared is really -9. So we have a 9 and a -9 canceling out, leaving us with just a -6i. And then multiplying that by 3i again gives us -18i squared. I squared is -1, so this is actually +18, and I'm adding that to -18, so I get my hoped-for result of 0 here. So that tells me I did all this correct, because I should get 0 if I'm actually plugging in one of the roots. Okay, now before I go ahead and rewrite the quotient using these crazy coefficients, I'm actually going to keep going and see if I can break this down a little bit further. Now, you might be wondering, what could I possibly use as my box number since I already used the one that they gave me? Well, this is one of those times where knowing a little bit of theory is very helpful. It turns out that if you have an imaginary number as one of the roots for a polynomial that has all real number coefficients, like this one, you also must have a root that's the conjugate of that imaginary number. You need something that, when you multiply it by 3i, gives you a real number. Otherwise, how could you multiply all of these factors out and get stuff that doesn't have any i's in it? So where there's one i, there must be another. In this case, we're going to have the conjugate of -3i. So that's what we're going to use as our next box number. In general, this is the strategy I'm going to use on all these problems where I'm starting with imaginary or complex numbers. I'm going to first divide using the number that they give me, then I'll use its conjugate to break things down a little bit further. So, bringing down this 1, we've got -3i times that, gives me -3i. The positive and the -3i's are going to cancel when I add these together, so that's just -2 left over from that. And -3i times -2 is +6i, which cancels out the -6i to give us 0. So then we end up with, we divided twice here, so instead of x cubed, now we're down to x to the first power, so this is 1x to the first minus 2. And I can set all of that equal to 0 now and just very quickly solve that. So at the end of this one, I have plus or minus 3i, and I also have x equals +2 from this branch right here. Looking for that in the answer choices, I think -3i and 2 are the ones that they didn't give me. So let me look for those. That's right here, that's O, so I'll put O above spot 1 here. Here's another problem. This one is a lot like the one we just did. So again, we'll start with synthetic division using -5i. So we have a 1 for coefficients, -3, 25, and -75. Box number of -5i. Bring down the 1 times negative 5i is still negative 5i. Can't combine it with the negative 3, so we'll write it as negative 3 minus 5i times negative 5i. We've got to distribute now, so we end up with 15i plus 25i squared. 25i squared is really negative 25 because I squared is negative 1. 25 and negative 25 cancels, leaving us with 15i. Times negative 5i gives us negative 75i squared, which is really positive 75. Negative and positive 75 cancels to give us 0. Now if I have a negative 5i as one of my roots, that means I must have a positive 5i as another of the roots. They always come in pairs, conjugate pairs. So 5i is my next box number that I'm going to plug in using these coefficients that I just got. So bring down the 1 times 5i is 5i. This cancels with the negative 5i here, so that leaves me with a negative 3 down there. Times 5i gives me negative 15i, and that cancels the 15i to give me 0. So that leaves me now, again, we started with x cubed and we lost 2 powers, so now we're down to x to the first, and then minus 3. So my solutions, we had the plus or minus 5i, and then this positive 3 that we got by doing synthetic division twice. 5i and positive 3, those are the things I'll be looking for in my answer choices. That's over here, that's an L, so that's going in spot 2. On this next problem, things are going to get a little bit trickier, but let's start with our synthetic division. So we have a 1, negative 6, 13, and negative 20. And yep, you read that right. We have a box number, a root of 1 plus 2i. That's one big complex number that we're going to have to use every time, which is what makes this a little bit tougher. So let's bring down the 1. 1 plus 2i times that is just 1 plus 2i, so far that's not too horrible. Negative 6 combines with this 1 to give me a negative 5 plus the 2i that's already there. And now I'm going to have to do 1 plus 2i times negative 5 plus 2i. So I'm essentially going to have to FOIL, double distribute those complex numbers together. So I'm going to do this in a couple steps so I don't lose track of anything. So we have the 1 getting multiplied by each of these. That's 1 times negative 5 is negative 5, and then times 2i is a plus 2i. Next we have 2i times both of these, so that's going to be negative 10i plus 4i squared. And let me combine these now. 4i squared is really negative 4. Negative 5 and negative 4 gives me negative 9. And then 2i minus 10i is negative 8i. So I have 13 combining with this negative 9. That's going to give me a 4, and I still have that negative 8i left over. Now I got to do this again. So we have 1 times the 4 and the negative 8i, so that's 4 minus 8i over here. And then 2i times 4 is 8i. 2i times negative 8i is negative 16i squared. I'm going to combine a few things in one step here. The negative 8i and the 8i are going to cancel out, which is great. This negative 16i squared is really a positive 16. So I have 4 plus 16, which gives me 20. So this whole thing comes out to 20, which conveniently cancels the negative 20 that was up here. So that really does come out to 0. All right, so next up we have to keep going here. So I'm going to divide synthetically by the conjugate of 1 plus 2i. So this time around I'm going to use 1 minus 2i. So bring down the 1 times this is going to give me 1 minus 2i. The positive and the negative 2i's cancel out conveniently, giving me the negative 4 there. And then multiply that out, we've got negative 4 plus 8i. Well, negative and positive 4 cancel, negative and positive 8i cancel, so that's all 0. So we have x minus 4 for my quotient after going twice with synthetic division. So my answers then, we have 1 plus or minus 2i, and also positive 4 from that last branch. So we end up with 1 minus 2i and 4 as the answers I'm actually looking for. C looks close, but we have a minus instead of a positive 4 there. R is what we need. 1 minus 2i, positive 4, so it's R going above number 3. Next up, we've got this crazy polynomial and the root of 2 minus 3i. So coefficients, let's get those. We have 3, negative 17, 59, and negative 65. And a box number of 2 minus 3i. So let's start by bringing down that 3, and we already have to work here and distribute. 3 times the 2 minus 3i, that's going to be 6 minus 9i right here. Negative 17 plus 6 is going to be negative 11 minus the 9i that we can't combine with anything. Now we're going to have to do 2 minus 3i times negative 11 minus 9i. We're going to have to FOIL this out. I'll put it up here and do it in a couple steps. So 2 times negative 11, that's negative 22. 2 times negative 9i is negative 18i. Negative 3 times negative 11 is positive 33i. And negative 3i times negative 9i is positive 27i squared. Positive 27i squared is really negative 27, plus another negative 22 gives me negative 49. And then negative 18i plus 33i is going to be a positive 15i. 59 plus this negative 49 gives me a 10, and I also still have that positive 15i. All right, time to do this dance again. 2 times 10 is 20. 2 times 15i is 30i, positive. Negative 3i times 10 is negative 30, which is good news. And negative 3i times 15i is negative 45i squared. 30i's are going to cancel. Negative 45i squared is really positive 45. 20 plus 45 is 65, which is going to cancel the negative 65 up here. So that's all 0. Next up, we're going to do another synthetic division using the conjugate of 2 minus 3i. So 2 plus 3i then. We'll start like we did before. Bring down that 3. 3 times 2 is going to be 6. 3 times 3i is now a positive 9i. So kind of like before, but a little different. Negative and positive 9i actually cancel. That's nice. And then negative 11 plus 6 is going to give me negative 5. 2 times negative 5 is negative 10. 3i times that, negative 15. 10's cancel. 15i's cancel. So that's 0. And we end up with 3x to the first minus 5 for that final quotient. So my answers, I've got 2 plus or minus 3i. And also if I set this equal to 0 and add 5 and then divide by 3, 5 over 3 is my other answer. So I'm looking for 2 plus 3i and 5/3. Ought to be pretty easy to find. Right there. So that's going to be P going in spot 4. So here we go again with another complex number. We've already done this dance a few times though. So far things don't seem to be getting worse. They're just staying at an uncomfortable level of synthetic division. So our coefficients, we've got 2, 17, 58, and 25. Box number of negative 4 minus 3i. So all those negatives are going to be kind of annoying. We bring down our 2. Distributing that, we have negative 8 minus 6i. 17 and negative 8 gives me a 9 minus the 6i. And now we're going to FOIL again, just like we've gotten used to doing on the last two problems. So negative 4 and 9 is negative 36. Negative 4, negative 6i is positive 24i. Negative 3i and 9, that's negative 27i. And negative 3i and negative 6i is going to be positive 18i squared. 18i squared is really negative 18. Added to the negative 36, we have a negative 54. And then 24i minus 27i is going to be negative 3i. 58 minus 54, that's going to be 4 minus the 3i there. Distributing this back out now, we have negative 16. Negative 4 times negative 3i is a positive 12i. Negative 3i times 4 is a negative 12i. And then negative 3i is going to give me a positive 9i squared. 12i's cancel. 9i squared is really negative 9, plus negative 16 is negative 25. Negative 25 plus this 25 up here is going to be 0. Now I'm going to divide again using these coefficients, and I'm going to use the conjugate, which is going to be negative 4 plus 3i. So only the imaginary number sign gets reversed here. So we bring down our 2 again. Distributing, we have negative 8 plus 6i this time. 6i's are canceling. 9 plus negative 8 is 1, which is really nice. 1 times that is just negative 4 plus 3i, which completely cancels the positive 4 minus 3i. So I have 2x plus 1 for my quotient. So my answers, we have negative 4 plus or minus 3i, and if I subtract 1 and divide by 2, we have a negative 1/2 as my third answer. So I'm looking for negative 4 plus 3i and negative 1/2 for the answers. I see that right here with u, so that's going to be spot 5 for u. So for problem number 6 here, things just got, well, I was about to say real, but they're still giving us imaginary numbers. This time, though, instead of having a cubic, we have a quartic, a 4th degree polynomial that we have to find all the roots for. Well, let's try synthetic division, right? Because although they only gave us 2i, they also are implicitly giving us negative 2i as the other root. So we can make this work and hope for the best. So we got 1 for my first coefficient, and then 2, negative 4, 8, and negative 32. That's the nice thing about synthetic division. It doesn't really matter how many terms you have, you can still do it. And then we have 2i for the box number. So bring down the 1, times 2i is 2i. 2 plus 2i is, well, we can't combine it, so I'll just leave it the way it is. 2i distributed to that, we've got 4i plus 4i squared. 4i squared is really negative 4. Negative 4 plus negative 4 gives me a negative 8 to go with that 4i that's there. Distribute the 2i again. We've got negative 16 plus 8i squared. 8i squared is really negative 8, which cancels the positive 8 here, leaving me with only this negative 16i. And then 2i times that is negative 32i squared, which is really just positive 32, canceling out the negative 32 up here to give us 0. All right, let's go again, this time using the conjugate, negative 2i. Bring down the 1. Times negative 2i is negative 2i. Conveniently cancels the 2i up here, leaving us with just 2. That multiplies to give me negative 4i, which cancels this 4i, leaving me with just negative 8. So this is working out great so far. This will be a positive 16i, which cancels the negative 16i, leaving me with just 0. So my quotient this time around, I've got 1x to the 2nd power because I started with 4th power and divided twice. So we're down to 2nd power now. And then this will be 2x and then negative 8. Now I can factor this. Numbers that multiply to negative 8 and add up to 2. 1 and 8 doesn't work, but 2 and 4 works if I have negative 2 and positive 4. So I'll split this up into x minus 2 and x plus 4. So my answers at the end of this one, I've got x equals plus or minus 2i from the beginning there, positive 2, and also negative 4. So then I'm looking for negative 2i, positive 2, and negative 4. And let's see here, negative 2i, I've got one of those right there. There's the 2, there's the negative 4, that's everything. So I'm putting an e in spot 6, but there's 2 spot 6s, so I'll get to use that one twice. And so we come at last, the end of a long journey, final boss battle. It looks just as awful as we would have imagined, and there's more than meets the eye going on with this one as well. So this is really a good final boss battle. Let's start with our coefficients. We have 1. And then we have not 41. There's a missing x cubed in there. We need a placeholder 0 for that. So right off the bat, this one is pretty nasty. Then we've got a 41 for real, 196, and a 212. And then our box number, 2 minus 7i, which is not ideal, but we'll take it. So we bring down the 1. times 2 minus 7i is still 2 minus 7i. Plus 0 is pretty easy. That's going to be 2 minus 7i right there. Now we have to multiply this by itself. So 2 times 2 is going to be 4. 2 times negative 7i is negative 14i. Negative 7i times 2 is another negative 14i. No surprise there. And then negative 7i is going to be a positive 49i squared. 49i squared is really negative 49. Plus the 4 here is going to be negative 45. And then we have a minus 28i as well. 41 plus negative 45 is going to be negative 4 to go with my negative 28i. And now I do the dance again. More foiling going on. So 2 times negative 4, negative 8. 2 times negative 28, negative 56i. Negative 7i times negative 4, that's going to be positive 28i. And then negative 7i and negative 28i. Well, let me think here. 7 times 28. I'm trying to do this without a calculator. Well, 7 times 20 is 140. 7 times 8 is 56. So this would be 140, 56. That's 196, and it'll be positive, and it'll be an I squared. So a lot going on in my head, but you could have used the calculator there. This is really negative 196, which added with the negative 8 gives me negative 204. And then we have negative 56i plus 28i, that's negative 28i. 196, negative 204, that all adds up to negative 8 minus the 28i. And here we go again, a third set of foiling. This is getting ridiculous. So we've got 2 times negative 8, that's negative 16. 2 times negative 28i is going to be negative 56i. Negative 7i times negative 8, that's going to be positive 56i, which I'm going to write here because I'm out of room. I can't go horizontally anymore. And then negative 7i times negative 28i, that's again going to be 196i squared. It's the same as last time, right? So this is really negative 196 plus a negative 16 is going to be negative 212, which is good. These 56 i's cancel, so all that I'm doing is doing 212 plus negative 212, which is 0. Whew! So, one round done. We got to go again, though. So we're going to use our conjugate of 2 plus 7i, and hopefully this is a little less nasty. So bring down that 1. 1 times that gives me 2 plus 7i. And thankfully, the 7 i's are canceling, leaving us with just 4 down there. Distributing the 4, we have 8 plus 28i. 28 i's cancel, leaves me with 4, which again distributes to this to give me 8 plus 28i. Everything's canceling now, the 8's and the 28 i's, to give us 0. So our quotient, we've got 1x squared, because again we started with x to the 4th and divided twice. Then we have a 4x and a plus 4, all equaling 0. Now I can factor this, things that multiply to 4 and add up to 4, that's 2 and 2. So I can write x plus 2 squared equals 0. And now my answers, I'm going to have 2 plus or minus 7i. And this parentheses here is giving me a double root of negative 2 as my other answer. So we're looking for 2 plus 7i and negative 2. And that's going to be right here with t. So we'll put that right there. So we've filled in all the blanks. Now it's time to solve the riddle. If figs come from a fig tree, where do chickens come from? They come from poultry. A slightly misspelled version of poultry, but true enough. Chickens come from other chickens, not a tree. Okay, till next time, Mr. Sutton signing off.